Hello everyone, I welcome you all to the e-videos prepared for the Anna University syllabus under the Regulation 2021. Today we are going to see the session on the topic scheduling algorithms in that shortest job first, that is SJF scheduling algorithm, which is otherwise called as shortest job next SJN scheduling algorithm. From the second unit, process management, in the course CS 3451, Introduction to Operating Systems. Myself, Dr. C. Rani. The objective of today's session is to know about SJF or SJN scheduling algorithm. And the outcome of the session, the students may be able to understand the SJF or SJN scheduling algorithm. Here is the outline of today's session. First, we'll discuss about the definition of job first scheduling algorithm and what are all the advantages and disadvantages of shortest job first scheduling algorithm and some of the solved problems. Let's see what is meant by shortest job next or job first SJF or SJN. SJF scheduling algorithm will assign the process that has the smallest CPU burst time for getting the CPU. So this algorithm is associated with each process CPU burst time. So this is a non-preemptive scheduling algorithm and which is the best approach to minimize the waiting time. And this SJN or SJF scheduling algorithm is easy to implement in the batch operating system where the required CPU time is known in advance. So for carrying out the shortest job first scheduling algorithm, we should be know CPU time in advance, that is CPU burst time in advance. And the advantages of this SJF scheduling algorithm, which will give a superior turnaround time for all the smaller processes, because the smaller processes will get executed first instead of a long process. So we'll get the turnaround time, a superior turnaround time, because a short job is given immediate priority or immediate preference. And the throughput is also high in case of using the SJF scheduling algorithm. The disadvantage is that elapsed time, that is the time taken for the execution completed time will be called as the elapsed time must be recorded, and it results in additional overhead on the processor. The starvation may be also possible for the longer processes. Let us start to focus on the problem. First problem, consider the following four processes P1, P2, P3 and P4. And here is the arrival time and the burst time of the processes. Four processes are given here. So first of all, if you want to apply the SJ shortest, if you solve the problem using or by applying the shortest job first algorithm, the CPU burst time is focused first. See which one is having the shortest or smallest CPU burst time? Process P2. So it will be executed first. The next process is P4. The next process is P1. The next process is P3. So the following problem is solved by calculating the start time, wait time, finish time, and the turnaround time. The waiting time is calculated from the difference of start time and the arrival time. So here the waiting time is start time minus arrival time. 0 minus 0, 0. 8 minus 1, 7. 17 minus 2, 15. 12 minus 3, 9. So from this, we have calculated the wait time. Then how to calculate the finish time? It is the addition of start time and the burst time. Start time and the burst time. 0 plus 8, 8. 8 plus 4, 12. 17 plus 9, 26. 12 plus 5, 17. So in this manner, we have calculated the finish time. Then the turnaround time is calculated by the difference of the finish time and the arrival time. So 8 minus 0 is 8. 12 minus 1 is 11. 26 minus 2 is 24. 17 minus 3 is 14. Now, we need to calculate the average waiting time and the average turnaround time. So, average waiting time is calculated by 0 plus 7 plus 15 plus 9 divided by, since we are having 4 processes, we need to divide it by 4. So, we get the average waiting time is 7.75 milliseconds. And the next we need to calculate the average turnaround time. It is 8 plus 11 plus 24 plus 14 divided by 4. We get 14.25 milliseconds. Next, we'll move on to the problem 2. So, the 4 processes are involved, and the burst time is given here and the arrival time is not given. So always, if you want to solve the problem using shortest scheduling algorithm, we need to focus on the CPU burst time, which process has the shortest or smallest burst time is process 4 is having CPU burst time is the smallest one, which will be executed first. The next process P1, which has 6 milliseconds CPU burst time, and then process P3 and then process 2. So the problem is solved using the Gantt chart, and we need to calculate the start time, wait time, finish time, and turnaround time. And waiting time is the start time minus arrival time. 3 minus 0. Since the arrival time is 0, we get whatever the starting time, that is your waiting time. So 3 plus 16 plus 9 plus 0 divided by 4 will be the average waiting time. We get 7 milliseconds. And finish time is calculated by start time plus the CPU burst time. 6 plus 3, 9. 16 plus 8, 24. 9 plus 7, 16. And 0 plus 3, 3. So, we need to calculate the turnaround time, which is the difference between the finish and the arrival. So, since the arrival is 0 for all the processes, whatever the finish time, that is your turnaround time. 9, 24, 16 and 3. In order to calculate the average turnaround time, 9 plus 24 plus 16 plus 3 divided by 4, we get 13 milliseconds. So the process which has the smallest CPU burst time is process 4, P4. So it will be processed, the processes will be processed in the order P4, which has the shortest CPU burst time is 3. Next, the next is shortest CPU burst time is 6. That is process P1 is getting the smallest, next smallest. Then next process P3, and last process that is processed is process P2. In this order, the Gantt chart is prepared, and we need to calculate the average waiting time and the average turnaround time. And coming on to the third problem, the 4 processes are there, and burst time is given and the arrival time is given. We need to calculate start, wait, finish, and turnaround time. So look at the CPU burst time for all the 4 processes. Which process has the smallest job first, that is CPU burst time is process P3. And that will be processed first. Next, process P2 and P4 has the same CPU burst time as 4 milliseconds. If it is so, then whatever the process that comes in first will be served first. Okay. Okay. So the average waiting time is calculated by 0 plus 6 plus 3 plus 7 divided by 4, we get 4 milliseconds. And the average turnaround time is 7 plus 10 plus 4 plus 11 divided by 4, we get 8 milliseconds. So after processing the CPU burst time is focused here. Process P3 followed by process P2 followed by process P4. After process P1 gets over, all the three processes are executed. So these are the references used for preparing the slides. Thanks for watching. In this video, we have come across shortest job first or shortest job next SJF or SJN scheduling algorithm. Thank you.